Hi student, now we start the exercise number 1.1 in the part of derivative, which is totally depend on derivative of composite function. We know very well the standard form of derivative and the standard form of derivative of composite functions. By using the rules of derivative and the standard derivative of composite function and the standard derivative of the differentiable function, we can solve every functions, every equations or every questions, every examples in exercise number 1.1. First example in exercise number 1.1 is y is equals to x cube minus 2x minus 1 whole raised to the power 5. If we differentiate the given function with respect to x, then clear that we get derivative of y. The derivative of y is dy by dx is equals to d upon dx x cube minus 2x minus 1 whole raised to the power 5. The given function is in the form of derivative of f of x whole raised to the power n. And we know that the derivative of f of x raised to the power n is n into f of x whole raised to the power n minus 1 into again a derivative of f of x. By applying this formula, we can write it 5 into x cube minus 2x minus 1 whole raised to the power 5 minus 1 is 4. And we take again a derivative of considerable functions, which is x cube minus 2x minus 1. After that, 5 into x cube minus 2x minus 1 whole raised to the power 4 as it is. The derivative of x cube is 3x square minus 2 is constant function and the derivative of x is 1 minus 1 is constant function and the derivative of any constant function is 0. Hence we can write it 5 into x cube minus 2x minus 1 whole raised to the power 5 into 3x square minus 2 into 1 2, which is the required derivative of the given functions. Next function, which is also composite function. If we differentiate the given function with respect to x, then the derivative of y is dy by dx is equals to d upon dx 2x whole raised to the power 3 by 2 minus 3 into x raised to the power 4 by 3 minus 5 whole raised to the power 5 by 2, which is also in the form of f of x whole raised to the power n. And if we take the derivative of f of x raised to the power n is n into f of x raised to the power n minus 1 into again a derivative of f of x. By applying this rule, we can write it n is 5 by 2 into 2x raised to the power 3 by 2 minus 3x whole raised to the power 4 by 3 minus 5 whole raised to the power n minus 1 means 5 by 2 minus 1 is 3 by 2. And we take again derivative of this considerable function, which is derivative of 2x raised to the power 3 by 2 minus 3 x raised to the power 4 by 3 minus 5. After that, 5 by 2 into 2x raised to the power 3 by 2 as it is minus 3 into x raised to the power 4 by 3 as it is minus 5 into whole raised to the power 3 by 2. We take the derivative, separate derivative of every terms. Hence we can write 2 is constant function, derivative of x raised to the power 3 by 2 minus 3 is constant function, derivative of x raised to the power 4 by 3 minus derivative of 5. After that, we can write it 5 by 2 into 2x whole raised to the power 3 by 2 minus 3x whole raised to the power 4 by 3 minus 5 whole raised to the power 3 by 2 into 2 is constant. The derivative of x raised to the power 3 by 2 is 3 by 2 into x raised to the power 3 by 2 minus 1, which is 1 by 2. Minus 3 is constant. The derivative of x raised to the power 4 by 3 is n is 4 by 3 into x raised to the power 4 by 3 minus 1, which is 1 by 3. Minus 5 is again constant and the derivative of constant function is 0. Now we can write it 5 by 2 into 2x whole raised to the power 3 by 2 minus 3x raised to the power 4 by 3 minus 5 whole raised to the power 3 by 2. Here 2 cancel. We can write it 3 into x raised to the power 1 by 2. 3 cancel. Minus 4 into x raised to the power 1 by 3 minus 0, bracket complete. Also we can write 5 by 2 into 2 x raised to the power 3 by 2 is under root of x cube minus 3 into x raised to the power 4 by 3 is cube root of x raised to the power 4 minus 5 whole raised to the power 3 by 2. Again, we can write x raised to the power 1 by 2 means under root x minus 4 into x raised to the power 1 by 3 means cube root x, which is the required derivative of y dy upon dx. Next example, y is equals to under root of x square plus 4x minus 7. And we know that derivative of root x is 1 upon 2 root x. In the under root, if f of x, then the derivative of under root fx is 1 upon 2 under root of fx into again a derivative of fx, which is a derivative of composite function. If we differentiate this function with respect to x, then the derivative of y is dy by dx, and derivative of under root of x square plus 4x minus 7 we can write by using the derivative of under root fx is 1 upon 2 under root of x square plus 4x minus 7 into again a derivative of x square plus 4x minus 7. It is clear that 1 upon 2 under root of x square plus 4x minus 7 as it is. After that, we can write derivative of every terms separately. Hence, the derivative of x square is 2x plus 4 into 4 is constant function and the derivative of x is 1 minus the derivative of 7, which is constant, is 0. Hence, we can write it 2x plus 4 upon 2 under root of x square plus 4x minus 7. After we take 2 common, we can write it x plus 2 upon 2 under root of x square plus 4x minus 7. If 2 is cancelled, then we can write dy by dx upon is equals to x upon 2 upon under root of x square plus 4x minus 7, which is the required derivative of given function. Next example, number 4, y is equals to under root of x square plus under root of x square plus 1, which is again in the form of derivative of root x, and we know the derivative of root x is 1 upon 2 root x. If the given function is in composite function, then we can write the derivative of under root of fx is 1 upon 2 under root fx into again derivative of fx. After differentiating, we can write the derivative of y dy by dx into d upon dx of under root of x square plus under root of x square plus 1. By using this rule, under root of fx, we can write this derivative 1 upon 2 under root of x square plus under root of x square plus 1, and we take again the derivative of x square plus under root of x square plus 1. 1 upon 2 under root of x square plus under root of x square plus 1 as it is. We can take a separate derivative of both terms by using the rules derivative of u plus v is du by dx plus dv by dx. It is clear that we know that the derivative of x square is 2x plus derivative of under root terms 1 upon 2 under root of x square plus 1. Again, we consider x square plus 1 is x. Hence, we can write again a derivative of x square plus 1. After that, we can write it 1 upon 2 under root of x square plus under root of x square plus 1 into 2x plus 1 upon 2 under root of x square plus 1, and the derivative of x square is 2x, derivative of 1 is 0, hence x square is 2x is equals to, here 2 cancel, we can write it 1 upon 2 under root of x square plus under root of x square plus 1 into 2x plus x upon under root of x square plus 1, which is a required derivative of y, dy upon dx. Next example, example number 5, y is equals to 3 upon 5 cube root of 2x square minus 7x minus 5 whole raised to the power 5. If we have to differentiate given function, first we simplify this function. We can write it 3 upon 5 separate, and a remaining function cube root of 2x square minus 7x minus 5 is 2x square minus 7x minus 5 whole raised to the power 5 upon 3. If this function we take in numerator, then we can write again 2x square minus 7x minus 5 whole raised to the power minus 5 by 3. After differentiating with respect to x, derivative of y is dy by dx. 3 upon 5 is constant function, and we can take a derivative of 2x square minus 7x minus 5 whole raised to the power minus 5 by 3. Thus, the given function is in the form of x raised to the power n. If we consider whole bracket x and power is n, then we apply here derivative of fx raised to the power n. And the rules of f of x raised to the power n is n into f of x whole raised to the power n minus 1 into again the derivative of fx. Thus we can write it 3 by 5 into x raised to the power n means minus 5 by 3 into 2x square minus 7x minus 5 whole raised to the power n minus 1 means minus 5 by 3 minus 1. After taking cross product, minus 5 minus 3 upon 3 is equals to 8 minus 3. Hence we can write the power of minus 5 by 3 minus 1 is minus 8 by 3. And we take again a derivative of considerable function 2x square minus 7x minus 5. After that, we can write it 3 cancel because both are multiple terms. 5 cancel is equals to minus 2x square minus 7x minus 5 whole raised to the power minus 8 by 3 into derivative of 2x square. 2 is constant function and the derivative of x square is 2x minus 7 is constant and the derivative of x is 1 minus derivative of 5 which is constant function is 0. After that we can write it dy by dx is equals to minus 2 into 2 4x minus 7 into 1 7 upon the power of 2x square minus 7 is minus 5 raised to the power minus 8 by 3. If we convert negative power into positive, then we can write this whole terms in denominator 2x square minus 7x minus 5 whole raised to the power 8 by 3, which is a required derivative of y dy upon dx. Next, the given example which is in the form of under root of 3x minus 5 minus 1 upon under root of 3x minus 5 whole raised to the power 5, and we can apply here derivative of x raised to the power n is equals to n into x raised to the power n minus 1 directly. If we differentiate the given function with respect to x, then we can write this function dy upon dx is equals to derivative of under root of 3x minus 5 minus 1 upon under root of 3x minus 5 whole raised to the power 5. By using the derivative of f of x raised to the power n, we can write it 5 into under root of 3x minus 5 minus 1 upon under root of 3x minus 5 as it is, and n minus 1 is 5 minus 1 is 4. Then we take again a derivative of under root of 3x minus 5 minus 1 upon under root of 3x minus 5. Next, 5 into, after taking cross product we can write it under root of 3x minus 5 whole bracket square minus 1 upon under root of 3x minus 5 whole raised to the power 4. We can take here the separate derivative of both function, hence we take a first derivative under root of 3x minus 5, and this term also we can write under root of 3x minus 5 is 3x minus 5 whole raised to the power 1 by 2. And if we take this term in numerator, then also we can write it 3x minus 5 whole raised to the power minus 1 by 2. Then again 5 into root m square is cancelled, 3x minus 5 minus 1 upon under root of 3x minus 5 as it is whole raised to the power 4. Derivative of root x is 1 upon 2 root x, hence we can write it 1 upon 2 under root of 3x minus 5 into again a derivative of this term 3x minus 5 minus, by applying the rules of x raised to the power n we can write it minus 1 by 2 into 3x minus 5 whole raised to the power minus 1 by 2 is n minus 1 by 2 minus 1 is minus 3 by 2, and we take the again a derivative of 3x minus 5. After that we can write it 5 into 3x minus 6 upon under root of 3x minus 5 into the derivative of 3x is 3, derivative of minus 5 is 0, 3 minus 0 is 3, 3 into 1 is 3, then 3 upon 2 under root of 3x minus 5 minus plus minus 3 by 2 right in denominator, hence we can write it 1 upon 2 into 3x minus 5 whole raised to the power 3 by 2. And again derivative of 3x is 3. Derivative of minus 5 is 0. And the derivative of 3x minus 3 minus 5 is 3. Hence we can write it into 3. After taking 3 common, we can write it 3 by 2 common. We can write it 5 into 3x minus 6 upon under root of 3x minus 5. If we take 2 common in this term, we can write it 5 into 2 x minus 2 into, if we take 3 by 2 common, we can write it 1 upon under root of 3x minus 5 plus 1 upon under root of 3x minus 5 whole raised to the power 3 by 2. Here 2 cancel. 5 into 3 is 15 into x minus 2 upon under root of 3x minus 5 into 1 upon under root of 3x minus 5. After taking cross product, we can write it 1 upon under root of 3x minus 5 plus 1 upon 3x minus 5 whole raised to the power 3 by 2, which is the required derivative of y dy upon dx. Now, question number 2 is differentiate with respect to x and the given function y is equals to cos of x square plus s square. Function is composite function, and we know that the derivative of cos x is minus sin x. If we consider that whole bracket is f of x, then we can write derivative of cos of fx, derivative of cos of fx is equals to minus sin fx into again the derivative of fx. Hence we can write it after differentiating with respect to x, the derivative of y is dy by dx, and the derivative of cos of x square plus a square, derivative of cos is minus, with minus sign of x square plus a square, we take the again derivative of x square plus a square. We know that the derivative of x square is 2x, a is constant function and hence derivative of x square is 0. 2x plus 0 is 2x. 2x into minus, it can write minus sign of x square plus a square into 2x plus 0. 2x into minus, minus 2x sign of x square plus a square, which is a required derivative of y dy upon dx. After that, second example, y is equals to under root of e raised to power 3x plus 2 plus 5. If we differentiate with respect to x, then we can write it dy upon dx is equals to derivative of under root x is 1 upon 2 root of x means e raised to power 3x plus 2 plus 5. And we take again derivative of under root functions, derivative of e raised to the power 3x plus 2 plus 5. After that we can take a separate derivative of every variables is equals to 1 upon 2 under root of e raised to the power 3x plus 2 plus 5 into derivative of e raised to the power 3x plus 2 is e raised to the power 3x plus 2, and we take again the derivative of 3x plus 2. 5 is constant function, hence the derivative of 5 is also 0. Now we can write it. Is derivative of 3x plus 2. 3x derivative of 3x is 3. 3 plus 0 is 3. 3 into e to the power 3x plus 2 upon 2 into under root of e raised to the power 3x plus 2 plus 5, which is the required derivative of y dy upon dx. After that, next example, y is equals to log of tan of x by 2. After differentiating with respect to x, we can write derivative of y is dy by dx into again derivative of log of tan of x by 2. If tan of x by 2 is considered function, then we can write the derivative of log x is 1 by x. Hence we can write it 1 upon tan of x by 2 into again a derivative of tan of x by 2. We know that the derivative of tan x is sec square x. Hence we can write it 1 upon tan of x by 2 into sec square x by 2. Again x by 2 is considerable function. Hence we can write it again derivative of x by 2. It is also can write as 1 upon 2 sine of x by 2 into cos of x by 2. We know that 2 sine theta into cos theta is equals to sine 2 theta. Hence we can write it 1 upon 2 sine of x by 2 into cos of x by 2 is 2 sine of 2 times x by 2. If we cancel 2, then we get 1 upon sine x, and 1 upon sine x also we can write it cosec x, which is the required derivative of y dy upon dx. Next one, example number 4 is y is equals to under root of tan x. If we apply this, after differentiating with respect to x, we can write the derivative of y is dy by dx into derivative of under root of tan of root x. By applying the derivative of under root of fx, we can write it 1 upon 2 under root of tan of root x into again a derivative of tan of root x. 1 upon 2 under root of tan of root x as it is. Derivative of tan is sec square x. Hence we can write the derivative of tan root x is sec square of root x into again a derivative of root x. Sec square root x into 1 is sec square root x upon 2 under root of tan of root x into derivative of root x is 1 upon under root x. Again we can write it 1 into sec square root x is sec square root x upon 2 into 2 is 4 under root x as it is into under root of tan of root x, which is the required derivative of y dy upon dx. After that, next example is 5. Y is equals to cot cube of log of x cube. We can write it cot of log of x cube whole bracket cube. Now this function is in the form of x raised to the power n, and we can write it differentiate with respect to x, derivative of y is dy by dx. If we apply the derivative of x raised to the power n, then we can write 3 into cot of log of x cube whole raised to the power 3 minus 1 is 2 into again a derivative of cot of log of x cube. 3 into cot of log of x cube whole bracket square as it is. The derivative of cot is minus cosec log of x cube as it is, and again we take a derivative of log of x cube. This log of x cube we can write also 3 log of x, hence we directly write log of x cube is 3 log x, and we know that 3 cot of log of x cube whole bracket square minus into plus is minus cosec of log of x cube. 3 is constant into derivative of log x 1 by x. Hence we can write it 3 into 3 minus 9 into cot of log of x cube whole bracket square into cosec of log of x cube, which is into 1 upon x upon x, which is the required derivative of y dy upon dx. Next example number 5 is in again form of cot cube log of x cube. We can write this function y is equals to cot of log of x cube whole raised to the power 3. This log of x cube we can write also is 3 log of x. Next example number 5 is y is equals to cot cube log of x cube. We can write also cot of log of x cube whole raised to the power 3. After differentiating with respect to x, we can apply here derivative of f of x means cot of log of x cube whole raised to the power 3 x raised to the power n. And we know that the derivative of f of x raised to the power n is equals to n into f of x raised to the power n minus 1 into again derivative of f of x. Hence we can write also it 3 into cot of log of x cube into again a derivative of cot of log of x cube. 3 into cot of log of x cube as it is. The derivative of cot is minus cosec square log of x cube into again a derivative of log of x cube means 3 log of x. After that plus minus minus 3 cot of log of x cube whole bracket cube 2 into cosec square log of x cube into the 3 is constant function and the derivative of log x 1 by x. Hence we can write it 3 into 3 minus 9 cot of log of x cube whole bracket square into cosec square log of x cube upon x, which is the required derivative of y dy upon dx. Next one is 5 raised to the power sin cube x plus 3. After differentiate with respect to x, we can write it dy by dx is equals to derivative of 5 raised to the power sin cube x plus 3. This function is in the form of derivative of a to the power f of x, and we can write the derivative of f of x is a to the power f of x into log a into again the derivative of f of x. By applying this rule, we can write this function 5 raised to the power sine cube x plus 3 into log of 5 into again the derivative of sine cube x plus 3. Now 5 raised to the power sine cube x plus 3 as it is into log of 5, and we have derivative of sine cube x is 3 sine square x into again a derivative of sine x by using the rules of derivative of x raised to the power n. 3 is again constant function and the derivative of constant function is 0. Hence we can write it 5 raised to the power sine cube x plus 3 into log of 5 into 3 sine square x into cos x, which is the required derivative of y dy upon dx. The next example is y is equals to cosec of under root cos x. If we differentiate with respect to x, then we get dy upon dx is equals to derivative of cosec of under root cos x. If we consider that under root cos x is considered function, then we can write the derivative of cosec x is minus cosec of under root cos x into again into cot of under root cos x into again the derivative of under root cos x minus cosec of under root cos x into cot of under root cos x, and we know that the derivative of under root cos x is 1 upon 2 under root cos x into again a derivative of cos x. Hence we can write derivative of cos x is minus sin x, then minus cosec of under root cos x into cot of under root cos x, and the derivative of cos x is minus sin x upon 2 under root of cos x. Minus minus plus, hence we can write it minus sin minus of minus sin x is sin x into cosec of under root cos x into cot of under root cos x upon 2 under root of cos x, which is the required derivative of y dy upon dx. Next one, y is equals to log of cos of x cube minus 5. After differentiating, y is dy by dx, and we take again a derivative of log of cos of x cube minus 5. We know that the derivative of log x is 1 by x, and the derivative of log of fx is 1 upon fx, and we take the again derivative of fx. Similarly, we can write here the derivative of log of cos of x cube minus 5 is 1 upon cos of x cube minus 5, and again we take a derivative of cos of x cube minus 5. The derivative of cos of x cube minus 5 is again minus sin of x cube minus 5 upon cos of x cube minus 5. X cube minus 5 is considerable function, hence we can take again derivative of x cube minus 5. The derivative of x cube is 3x square. Derivative of minus 5 is 0. Hence we can write minus of sin upon cos is tan of x cube minus 5 into derivative of x cube is 3x square, and minus 5 is 0. Hence we can write it minus 3x square into tan of x cube minus 5, which is the required derivative of y dy upon dx. After that, the next question is y is equals to e raised to the power 3 sin square x minus 2 cos square x. If we differentiate this function with respect to x, then the derivative of y is dy by dx into again a derivative of e raised to the power 3 sin square x minus 2 cos square x. We know that the derivative of e to the power x is e to the power x, hence we can write it e to the power 3 sin square x minus 2 cos square x into again a derivative of 3 sin square x minus 2 cos square x. We can take a separate derivative of 3 sin square x and minus 2 cos square x. Then we can write e raised to the power 3 sin square x minus 2 cos square x as it is. Again 3 is constant function. We take a derivative of sin of x whole bracket square minus again 2 is constant function. We can take a derivative of cos of x whole bracket square. Then e raised to the power 3 sin square x as it is minus 2 cos square x. 3 is constant. By using the derivative of x raised to the power n, we can write here derivative of sin square x is 2 sin x into again derivative of sin x is cos x minus 2. By using the derivative of x raised to the power n, we can write the derivative of cos of x cos square x is 2 cos of x into again derivative of cos x is minus sin x, minus sin here into sin x is equals to e raised to the power 3 sin square x minus 2 cos square x as it is into 3 into 2 sin x is a 2 sin x into cos x is in the form of sin 2x because sin 2 theta is equals to 2 sin theta into cos theta. Hence we can write 2 sin theta into cos theta is sin 2 theta. Therefore 2 sin x into cos x is sin 2x minus minus plus 2 into 2 4 minus minus plus 2 into 2 sin x into cos x again we can write sin 2x is equals to e raised to the power 3 sin square x minus 2 cos square x into here we take sin 2x common, hence sin 2x means 3 plus 2 into sin 2x. 3 plus 2 is 5. Hence we can write 5 sin 2x into e to the power 3 sin square x minus 2 cos square x, which is the required derivative of y dy upon dx. Next one, y is equals to cos square log of x square plus 1. After differentiating with respect to x, we can apply here derivative of cos of log of x square plus 7 whole raised to the power 2. By using the derivative of f of x whole raised to the power n is equals to n into f of x whole raised to the power n minus 1 into again derivative of f of x. Therefore, we can write it derivative of cos x whole raised to the power n is 2 cos of log of x square plus 7. 2 minus 1 is 2 into again derivative of cos of log of x square plus 7. After that 2 cos of log of x square plus 7 as it is. The derivative of cos is again minus sin of log of x square plus 7 into again a derivative of log of x square plus 7. After that, okay, we can write 2 into minus 2 sin of log of x square plus 7 into cos of log of x square plus 7, and we take the derivative of log of x square plus 7 is 1 upon x square plus 7 into again a derivative of x square plus 7. We know that 2 sin theta into cos theta is equals to sin 2 theta. Hence we can write it 2 sin of bracket into cos of bracket is equals to sin 2 bracket minus sin of 2 log of x square plus 7 into derivative of x square is 2x and the derivative of constant function 7 is 0. Hence 2x plus 0 is 2x. 2x into 1 is 2x. Hence we can write 2x upon x square plus 7, which is the required derivative of y, dy upon dx. Next example, y is equals to tan of cos of sin x. This is also a composite function. If we differentiate again derivative of y is dy by dx. This function is in the form of tan x, and we apply here the derivative of tan of f of x, then we get the derivative of tan x means sec square of f of x into again derivative of f of x. After applying this form, we differentiate with respect to x. The derivative of y is dy by dx. The derivative of tan is sec square into cos of sin x. This cos of sin x is considerable function, hence we can write the again derivative of cos of sin x. Sec square cos of sin x as it is. The derivative of cos is minus sin into sin of x. We take again a derivative of sin x. This minus sin minus of sec square cos of sin x as it is into sin of sin x, and again derivative of sin x is cos x. Hence we can write dy by dx is cos x into sin of sin x into sec square cos of sin x, which is the required derivative of y, dy upon dx. Next example, which is y is equals to sec of tan of x raised to the power 4 plus x. If we differentiate with respect to x, then we get the derivative of y is dy by dx. Then again we can write d upon dx of sec of tan of x square plus 4. Here we can consider whole bracket x. By applying the derivative of sec x is sec x into tan x. It means that sec of tan of x square plus 4 into tan of x square plus 4 into again a derivative of, consider bracket, derivative of tan of x square plus 4. Again we can write sec of tan of x square plus 4 as it is, tan of x square plus 4 as it is, and we know that the derivative of tan is sec square, hence we can write here sec square of x square plus 4, and we take again a derivative of x square plus 4. After that, we know that the derivative of x square is 2x, derivative of 4 is 0, 2x 4 plus 2x plus 0 is 2x, we can write it 2x. After that, sec square of x square plus 4 into sec of tan of x square plus 4 into tan of x square plus 4, which is the required derivative of y, dy upon dx. After that, next example, y is equals to log base c log of x bracket square minus log of x square. We know that a to the power log base a of fx is equals to f of x. Hence we can write here e to the power log base e means y is equals to log of x whole bracket square minus log of x square. Again this function we can write y is equals to log of x square minus 2 log of x. If we differentiate the given function with respect to x, the derivative of y is dy by dx. We can take a separate derivative log of x bracket square minus 2 into derivative of log x. Here we apply the derivative of x to the power a, then we get the derivative of log of x bracket square is 2 log of x into again a derivative of log x minus 2 is constant function and the derivative of log x 1 by x. Hence we can write this 2 log x into the derivative of log x is 1 by x minus 2 into 1 by x. If we take 1 by x common from these two terms, then we can write 1 upon x into 2 log x minus 2, which is the required derivative of y dy by dx. Also we can take 2 common this whole two terms, then also we can write 2 upon x into log of x minus 1 or 2 into log x minus 1 upon x, which is a required derivative of y dy upon dx. Next one, y is equals to sine of under root x. This function, which is a composite function and is in the form of sine of fx. If we apply the derivative of sine of fx, then we can write cos of fx into again the derivative of fx. Similarly, we can write here. Now after differentiating with respect to x, dy upon dx, we can take a derivative of sine of under root of sine of root x. The derivative of sine is cos, hence we can write it again, so cos of sine of root x, and we take again a derivative of sine root x. We know that derivative of root x is 1 upon 2 root x. Cos of under root of sine of root x as it is. Derivative of under root sine of root x is 1 upon 2 under root of sine of root x into again a derivative of sine root x. Cos of under root of sine root x as it is 1 upon 2 sine under root of sine of under root x as it is into derivative of sine is cos, hence we can write the sine of root x is cos of under root x into again a derivative of root x. Cos of root x into cos of under root of sine of root x is cos of root x into cos of under root of sine of root x upon 2 under root of sine of root x into again a derivative of root x is 1 upon 2 root x. After multiplying, we can write cos of root x into cos of root of under root of sine of root x upon 2 into 2, 4 under root x into under root of sine root x, which is the required derivative of y dy upon dx. If we differentiate this function, first we simplify it. If the given function is log x base e square, then we can write it log x upon log of e square by using the rules of log of m base n is equals to log m upon log n. Then again, log of m raised to the power n is equals to log of n log of m. Hence we can write it log of log x upon 2 log of e. We know that the value of log is 1. Hence y is equals to 1 by 2 into log of log x. If we differentiate this function with respect to x, then y derivative of y is dy by dx. 1 by 2 is constant, and we take a derivative of log x. 1 by 2 as it is. Derivative of log x is 1 upon log x into again derivative of log x is equals to 1 upon 2 log x. Again we know that the derivative of log x is 1 by x. Hence we can write it 1 upon 2x log x, which is the required derivative of given function dy upon dx. Again function y is equals to log of log x whole raised to the power 2. After differentiating, we can apply here the rules of derivative, which is in the form of x raised to the power n or f of x raised to the power n. Here the value of n is 2, and this function log of log x whole bracket square. We take a derivative of bracket raised to the power 2 is 2 into log of log x whole raised to the power 2 minus 1 into again the derivative of log x. Here 2 into log x as it is. The derivative of log x is 1 upon log x. Again we take derivative of log x. After that we can write again 2 into log x upon log x into again derivative of log x is 1 upon log x, and we take again a derivative of log x. We know that the derivative of log x is 1 by x. Hence we can write 2 log x upon log x into 1 upon log x into 1 by x, which is the required derivative of y dy upon dx. Last example in this question, y is equals to sin square x square minus cos square x square. After differentiating with respect to x, we can write the derivative of y is dy by dx. We take a separate derivative of sin of x square whole bracket square minus derivative of cos of x square whole bracket square. After applying x raised to the power n here, we can write 2 sin of x square into again a derivative of sin x square minus 2 cos of x square into again a derivative of cos of x square. The derivative of sin of x square is 2 sin of x square into cos of x square into again a derivative of x square minus 2 cos of x square into derivative of cos of x square is minus sin of x square into again a derivative of x square. Here 2 sin of x square as it is into cos of x square. We can write the derivative of x square is 2x minus plus here 2 cos of x square into sin of x square into again a derivative of x square is 2x. Here 2 sin theta into cos theta is equal to sin 2 theta. After applying the derivative, we can write it 2 sin of 2x square into 2x plus sin of 2x square into 2x. 2x sin of 2x square plus 2x sin of 2x square is 4x sin of 2x square, which is the required derivative of y dy upon dx.